Hello.
Hey,
What actually, my name is Nicholas Matsakis, but I would like you to introduce yourselves um, for the camera, if you will, starting with Nick.
uh, okay. Hey, I'm Nick Fitzgerald.
And I'm Alex Crichton.
And what do you guys work on? What brings you here?
I work on Rust and WebAssembly when they come together like Voltron.
Wow.
I don't quite have a reference lined up like that, but I'm here because Nico wanted to talk about WebAssembly and Async and Rust, and
I
we work
do.
on that.
I have a lot of questions. Um, so, so you can actually see some of them probably on your screen right now. The first one I want to know is kind of what the heck Rust async and WASM might have to do with one another. I mean, I understand that maybe backing up just a little bit, like JavaScript has promises. They're kind of like Rust futures. They're different. Um, so maybe the best first question is like, just looking at today, what is the kind of state of the world in terms of interacting with like Rust and JavaScript promises? And then maybe going from there, what do we think might happen to WASM, sort of independent from JavaScript, that would support async IO. But so can you now, if I'm writing a WASM thing in Rust and I have some JavaScript code that uses promises, can they interact and how?
I think it makes sense to back up just like one step before we dive into that even, which is just to say that like on the web, at least, like all the IO that you're doing, all of it's async pretty much. And so having good support for asynchronous code is really critical on the web. And then, yeah, it's talking about just how you do that today. Basically, we have conversions between JavaScript promises and Rust futures. And so if you're not using, beta and async await, then you're using futures combinators by hand, essentially. And then things kind of we have an executor that basically just hands the Rust future to JavaScript as a promise and lets the existing event loop kind of drive it to completion.
Hands the Rust future to JavaScript as a promise. So if I create a Rust future, it's kind of different, right? The JavaScript model, when I make a promise, it starts like right away, it kind of gets spawned, so to speak. But in the Rust model, you have to explicitly spawn it. So when you say you hand the Rust future to the JavaScript event, you're saying if I spawn the Rust future or something like that, it gets wrapped in a promise.
Correct, yeah. I dropped in a few links there. Like we have a crate that says the bridge of all this, and then some documentation. And so there's basically a bridge both ways. If you can take a JavaScript promise and then create a Rust feature, or you can take a Rust feature and create a JavaScript promise. We don't actually call that spawn. We actually call it feature to promise. But there's also a function called spawn, which just doesn't actually return the promise itself.
If I click on these links, will I see some example?
Click the second link, and you'll see some better examples.
Okay. Oh, wow. Okay. What's happening here? What's this one? What's this first example doing?
So that's an example of, first off, this is just an async function in Rust, kind of what you would expect with async await. The first line is creating a JavaScript promise, but you typically get that from somewhere else. This is just creating an immediately resolved one. The second line is what you actually do to actually get that into Rust. So you use the WASM by gen futures crate, you create this Rust type, which implements the Rust future trait, and once you do that, you can just call it .await, and it's good to go. And then everything, so in JavaScript, you can have features either resolve with a value or with an exception being thrown. And so we model that as a result where you either get a result of some sort of JS value, either the OK resolved or error through an exception, and you get to propagate that, deal with whatever you want in WebAssembly.
So at a lower level, this is basically converting from a JavaScript value into a Rust future, right? And I guess that it makes some sort of channel or something such that so like the poll method that futures have, when I poll, I'm basically asking, did the JavaScript code get around to executing this yet. Is that right?
Yeah, the fundamental interface of a JavaScript feature is you register a callback to happen when the value gets available, and so we shove a callback in there saying, oh, when the value becomes available, put that somewhere, and then go call the waker if one's waiting.
Yeah, so it's kind of like a channel. That's what I mean.
Yeah.
Okay, that makes sense. And for going the other way, I guess you wouldn't have I/O in the Rust, like the base I/O futures are always coming from JavaScript in this environment. You wouldn't like open a file using Rust APIs. Or at least if you did, we can get to that, I guess. They would have to be grounded in some other, it would be implemented in terms of JavaScript promises ultimately, or in terms of system base level promises.
Of like something provided by the operating system in C or whatever, it ends up being JavaScript from the web.
Yeah. Okay. So I was going to ask something like, well, what about going the other way? And I'm still sort of wondering. So when I get a Rust future, I guess somewhere, I guess that's the spawn thing we were talking about, right? So like this get from JS, this async function, if I want that to actually execute, I have to kind of turn it itself into a JS promise somewhere. And what did you say that was called? Into promise or something?
Future.
Actually, yeah, if you want to go back to the Dropbox paper doc, and then the first link is the API docs for this crate.
Okay. Future to promise.
Yes.
Makes sense.
And
have you built?
Well, basically just ignores the return value.
Okay. So that's kind of future to promise and then do nothing with it. Drop it on the floor. Have you built kind of cool examples using this? Or not cool examples?
Yeah, let me drop a link in there actually. Trying to remember the name of it. We have like 15 different, there we go, fetch. And okay, there we go. So if you want to open up that link, this is all the source code, but the more interesting one is probably click the view compiled example online. Oh wait, not that one. The one above it.
Oh, of course. Yeah, that's my local host. Yeah, good thing I'm not running some.
And if you open up a console here, like a developer console.
I don't even know how to do that. Apple Pay or something.
Control Command Shift I.
I did it.
So what you can see here is, we can go back to the source code in a second, but this is fetching via the GitHub API the current master commit of the WebAssembly repository. It's then using Serde to deserialize all of that and print all that out. And so this is kind of printing both like the native JavaScript object. And so this is like using the fetch API in the web and kind of dealing with all the promises there. So if you want to go back to the code, we can kind of take a look. It should be pretty small. Just go into the source, yeah. So we're using one of the crates, which gives us this request type and the fetch function. And so you can see here, like we're exporting an asynchronous function, which is just going to get turned into promises on the JS side. So we're not actually explicitly using a lot of the WebAssembly feature stuff here, except for
this is the crate you're talking about, WebSys.
Yes.
So that's basically like some kind of wrapper around, sort of Rust layer around the base APIs. Okay.
And that's the one that's it's sort of like the source of the features in this case.
Mm-hmm.
And so it's on line 51 is where we first actually spawn off the work. So we use the general window we call fetch with the request that we've created, and then we just immediately await it because we're just going to wait on that for that to be coming through.
Okay, I see. So you make here, you get back a JavaScript promise. We convert that to a Rust future, and then we await for it. Now we've got some JavaScript value, probably.
Yeah, so this is the next line is actually just an assert just to show you that it's the response type of on the web, and then given that response type, we can then call its own JSON method, which returns another promise, and we just immediately convert that to a Rust future, await that, and then they keep going doing some Serde stuff and printing that out.
Is this into Serde? Is that defined on like all JavaScript values or something. Okay. Anyway, I see. It makes sense. My other question now is this: what's happening here? So this is making a run function. WASM bindgen is for exporting to. You will be shocked how ignorant I am of the details here. Is for exporting things that you can invoke from JavaScript code. Is that right? So when you export an async function, do you get like a JavaScript async function on the other side? What happens?
Yes. That'll so this is the WebAssembly attribute just says make this so I can import it, and then the async keyword here means that, oh, this is a feature returning thing. So actually it's going to wrap it all automatically in that feature to promise function, and then that'll just return the promises back over to JavaScript.
So is this like, I'm just guessing here, but this is where it actually, right here is where it actually gets called, probably?
Exactly. It's actually, if you
it's pretty slick, you guys.
Go to your third tab, which is the book documentation, or the promises and future stuff.
Yeah, this one?
The one above it.
Okay. Oh, I see.
Sorry, I'm numbering the wrong way.
You're counting from 1, not 0.
Yeah, don't worry about it. But it's the this async fn foo. So just beneath that, you can kind of see how it's imported just the top of your screen right now. Yeah, and so that's how you're both importing it. You're using it like you're just kind of using the async syntax on both sides, and everything just works out. And so this is an async function in JavaScript calling an async function in Rust, using async await on both sides to thread it all through.
It's neat. Okay, makes sense. And so this wrapping glue code basically probably more or less invokes the function that creates a promise and then returns it. Right? Okay.
Correct.
Okay. All right. So the current state is pretty cool and allows to do a lot of interop. So actually, like, what's missing from this state then, in your mind? Or maybe nothing.
About like, 6 weeks until it's stable.
Okay. Like well, I guess I could imagine that JavaScript promises are maybe in pretty good state. Maybe you want, it seemed like there was a certain amount of like manual back and forth. It's kind of annoying. Maybe that's inevitable. But like, so like maybe there's some amount of wrapping around the APIs is what I'm kind of getting at. It could be done, but but like the fundamental features that you want is probably more or less there. What about things like JavaScript has some notion of streams, right?
It does, yeah.
Function star or something.
Yes, right.
Well, it has generators, and then it also, I think async generators are like in progress. I haven't been following super closely. And then there's also a streams type. So there's a lot of stuff here. But yeah, I think async generators can be async iterables, and I think streams are also async iterables. Till would be the right person to talk to about this because he's actually involved with TC39.
Yeah. Okay, that's all right. It's kind of JavaScript specific, but
yeah.
But I guess that's the answer. That there's still probably maybe some kind of work to make stream interop smooth.
Yeah. I think you had earlier mentioned kind of just general bindings. This is where I think the ecosystem still kind of needs to catch up around the WASM stuff. Where like, I think the surf crate has support for just if you just use it, it'll work with WASM. But I don't think many other higher level like HTTP, UDP protocol style crates will work with WebAssembly. And this is because the raw interfaces they're always built on TCP and whatnot don't actually exist on the web. Like you can't get a raw TCP stream, and so. And that's sort of like an example with HTTP, but in general, the web sys crate, which is the source of these promises, is very untyped. It just gives you a bland promise that has 2 values, and so there's not I think there's the glue crates that we have in the WASM bindgen ecosystem are kind of working to put layers of types on top of that and say like, oh, when you get this promise, it's actually a promise of like this type and that error. But we're still working on that. It still takes some. That's kind of like so not so much from like the language side, but certainly on the ecosystem side, I think we have some distance to go to make it really nice to use just general promises in async and JS.
Yeah, I was just thinking about that. So surf. I don't remember the details, but surf like bottoms out, I guess, and calls to fetch or something like that if you configure it properly. Or
I think so, yeah.
That's nice. Um, what is GLOO? Is that a crate that I should know? I feel like I should know this. I feel like I've been told.
It's basically trying to provide a bunch of these kind of typed wrappers, nice rusty APIs on top of WebSys, because WebSys is really pretty much like libc or something, right? It's pretty low level.
Okay.
And rather than just kind of being unsafe, it's just untyped. And so what these are doing is trying to give you the nice Rust types that you would want. We just had our first case.
Okay. Yeah. So glue is sort of like but it still kind of closely maps to WebSys, but it's just nicer.
Yeah, it's like how you would want these APIs designed if they were designed for Rust rather than JavaScript, essentially. And the idea is not to create like a whole framework, but to provide like a modular toolkit where you can kind of pick and choose which parts you want, because that's really important for people that are not writing whole web apps in Rust, but are instead like just writing one component that integrates into a larger system. And people who care a lot about things like code size and all of that.
Yeah. Do you envision, I guess it's hard to know now, I'm wondering how much we would expect people to be working with things sort of like Surf or other layers. I could imagine like web frameworks or whatever having multiple backends. In other words, writing against a Rust layer that can be targeted to the browser or other places versus writing kind of directly to the browser.
I think this is the most exciting thing for the WASM space about async is just that like the more that everyone else gets on board with async, the easier it is to write these kind of thin layers that abstract exactly what you're asynchronous over. And then because like you often end up with the web as like a secondary target, right? Second class citizen. And I think we can kind of really like lift the whole ecosystem up if we build more crates like Surf that just do the thing no matter where you are, even with WASM. I think that's maybe a Fireflower or something, or maybe it's a Fireball, I don't know.
So another question I had that maybe doesn't make sense is I feel like another big role for async in JavaScript has been dealing with events, so like GUI DOM events and things like that. And I'm wondering whether there's been any work like wrapping that and letting you write nice web-based GUIs in WASM, Rust. I don't know, plug it into Electron or something to package it up. Is that a thing? Or is that future work? Or neither?
We have definitely seen some of that. That's kind of when you get into like the more style, like there's a larger framework, so you have a lot of like a lot more decisions being made all at once. You have kind of a general framework that everything is falling within, and you kind of are using a lot of that. I know. I think one of our community members, Powan, is working on this one called Dominator, which I believe uses a lot of async concepts and kind of making it very, very low cost, very ergonomic to use and things like that. In general, though, we don't have like, there's not like a raw binding for like translating events like event listeners into some sort of something async. Like it's async-ish, but it's more like callback async as opposed to like future async. And so we haven't done there's not like a little interface we have for just that setup.
Yeah.
Well, I mean, there's a few things we've done. I mean, there's multiple frameworks out there that people have created.
That's true.
And I think like part of the challenge is trying to not lock things into frameworks, but instead build libraries that like everyone can use, even if you're not, building a whole thing from scratch. But I think like events are like one part of making a nice GUI, right? And I think a lot of it is like wrapping the DOM APIs in nice ways. And so what Dominator is doing is it's using kind of like an FRP style of thing where you have signals that always have a value, and then maybe you map over these signals and all of that. And another approach is like things like web components or virtual DOMs. And so we did build Dodrio.
I want some kind of like, meet cute example here. Oh well, I'm not going to get one, am I? Oh, it's kind of not bad. What's Dodrio?
So Dodrio is basically like, how can we make virtual DOMs for Rust and WASM from the start, and kind of the.
I remember this blog post. Yeah.
It's basically about how to best do memory management in this sort of virtual DOM world, taking advantage of kind of what Rust is good at and what WASM is good at, and then reusing that on the web ways that are kind of, if you were to try to do that with JavaScript, it would be painful.
Okay. All right. Enough about JavaScript. I want to ask about what is like preliminary thoughts, if any, about WASM. Sort of, is there an async story around WASM that doesn't involve JavaScript? And I understand that's pretty early days, if it's anywhere at all, but maybe you can say a few things about it.
Yeah, this is one, in terms of what's left, this is probably the next biggest one, and it's not super related to Rust. It's definitely not like the rustier language on our end, but there's not a great story for this right now. I'm not sure there's really any story in terms of if you have just sort of if you have WebAssembly outside of a browser, outside of the JavaScript environment, then you don't actually have, you just have imports and exports, and they're just completely arbitrary, and so there's no like predefined meaning for any of those. And so in that sense, just sort of a bare WebAssembly module doesn't really have a lot of support for WASM, just features or async stuff in terms of you would have to bring your own runtime. You'd have to define everything. And so the main effort to do this is the WASI, and sort of trying to define a standard set of APIs, which if you import from these modules and you get these meanings, you get these utilities and things like that. And so I think this is one of the next major aspects of WASI is going to be figuring out its own async story. Right now, it has a bunch of file system APIs, but they're all blocking, and it doesn't actually have like support for HTTP or TCP or UDP. And so I think those are in development. Everyone wants to add them and wants to see them come up. But so that's sort of like where I think a lot of the development will be happening, is adding async support to WASI. And I really hope that the Rust side of things, like what we've learned in Rust and features in Async IO and our whole ecosystem, we can actually take to WebAssembly and kind of use those ideas to inspire what those low-level APIs look like and everything like that.
Yeah. So okay, that all made sense to me, except for me saying silly things in the Dropbox paper comments. But But I want to talk a little bit more about Rust inspiration, and I want to just repeat what you said to make sure I actually understood it. So basically, right, WASM, if you don't have the browser, you have nothing. WASI is meant to bridge that gap. It provides, okay, good, I'm glad I made that up. I don't know why it just looked right, but also wrong. WASI is meant to sort of bridge that gap and provide kind of something you can program against. And so essentially, like, a lighter weight version, I guess, of API. Like, right, if you're in a browser, you have all these web APIs, sort of the web platform, and WASI is kind of meant to be a lighter weight version of that, I guess, that's more broadly applicable to other contexts, and it's also a little a la carte, I assume, so that you can sort of pick and choose what makes sense in your context.
Exactly.
And when you said Rust inspiration, I assume you're referring kind of to the poll model of futures versus the spawn model or completion model, I guess, of promises, or did you mean something else?
No, I mean exactly that, and I don't really quite know what it means to be inspired by Rust or to how to put that into WASI. Like, I'm not really sure WASI will get the notion of a feature itself, but we're going to, like, eventually async APIs will be designed for IO and things like that. Like, taking the stuff that we've succeeded with polling versus callbacks might be something good to put in there to make sure it works out.
And the assumption is, if you were running this in the browser, you would have WASI available too, right? And I assume, and it would sort of be converted into web platform APIs or just natively implemented, I guess. Is that correct?
There are JavaScript polyfills that, so essentially WASI is a set of imports, kind of like well-known imports, and there are JavaScript polyfills that provide those imports for WASM modules on the web.
Okay, right. And so when you said you don't know if WASI will have a notion of a future, you meant maybe it'll export some like APIs like epoll but not epoll, that sort of let you test for readiness and so on, and then you could build a future notion on top of that, like Rust has done. Is that what you mean? Or maybe it'll have a more first-class notion somehow. You don't know. Do that make sense?
Wait.
It does. Yeah, I mean, like, it makes more sense to have something Mio-ish of just kind of polling and notification than kind of objects that you attach callbacks to and all the allocations that implies, right? For a system level interface.
Right. Yeah. So I guess that's kind of the question, is like, WASI is really meant to be this pretty low level kernel-like interface. Something. Okay.
That's the thinking, although I have seen that I think there's a meeting soon about talking about an HTTP API for WASI, which I find interesting in terms of like, it's not the lowest level, it's not like TCP or it's not UDP, so you're not having to implement HTTP2 or HTTP3 in the WASI module. And so I think exactly how low level WASI is still sort of up for debate, and it's still sort of like something we're figuring out.
Yeah.
Right. There's also been talk about having multiple layers, because there's different situations where you might want to expose those low layers, or there's situations like I don't know, edge stuff or whatever, where you're sandboxing the WASM module and you don't want to give it raw TCP or whatever, but you do want to give it this high level HTTP API.
Okay, that makes sense. Oh, that's interesting. I guess I hadn't really thought about that, but yeah, that you might only want the high level ones.
There's some concerns as well, I think, or not concerns. There's design points about WASI is very capability driven, where you can't really do things unless you have a predefined capability to do that. So like, you can't open a file unless you already own the directory that you're opening within. And I think TCP might be pretty similar. Like, you could hand off, like, you have made an HTTP request and therefore can read and write to it, open channels, but it's a little more fuzzy if it's like, oh, you can open any TCP socket to anyone.
Right.
And then you have to like implement DNS yourself and all that. So anyway, that might be like, that's another driving factor for a lot of WASI APIs, is how to deal with access controls and how to deal with those permissions.
Yeah. So I think I recall hearing something about, like, I give you an open connection, you can use that connection, but that's the only thing you get to use, which is pretty cool. Okay, so there's a lot to be figured out here. What if it were that the model was somewhat higher than, like, how complex can the objects that WASI talks about be? In other words, are they just like a kernel level interface is like, numbers and pointers, I guess, back into your address space, for the most part. Is that comparable? But it sounded like if you were going to like use an HTTP library, you want to be able to say things like, give me the headers. That's like a vector of strings.
So WASM has these things called anyrefs, and then coming are just other typed objects as well, where anyref is kind of a reference to any sort of object. And these things are actually unforgeable. So they're not, an integer under the hood or whatever. The WASM can't make it up out of the blue. And so that's really the key to the whole capability model, is that you can't fake it.
Yeah, that makes sense. So this relies on like the GC integration work and so on. It's all building on that, or not?
It's defined by the host what the anyref actually is. It doesn't require garbage collection, but it does require some form of like reference counting or something to be tracked there to know when it can be deallocated. So it's not hard tied to GC, but it is like arbitrarily complex and defined by the host.
Okay, but if when I give an anyref to WASM, it gets put into one of those tables. Or sorry, I'm like jumping all around, but I have in my head now that there's like some linear memory, and then there's a side list, which is basically my mental model, a vector of anyrefs, and I talk about them.
In Rust, they will be spilled pretty much immediately into an anyref table. But there's nothing kind of fundamental about WASM that says that they have to go in this table. And if you don't ever put it in a table, then like it might as well be a raw pointer, right? It could just be a borrow. It's always just on the stack. There's no management that needs to happen.
It basically can't escape anywhere because there's just nowhere to escape to. Like like the heap and everything is the linear memory when it can't go in there, or a table, I guess, and it could go in there, but
Yeah.
that would be what we, okay.
But the table is also controlled by, the host, so.
Yeah, but WASM can put store and load from this table by index or something.
Yes.
There's instructions for that. Okay.
And then WASM has its own stack, like it's a stack machine, and then that stack can have any ref values on it. But that's the only two places that any ref values could live. Inside of tables or on the WebAssembly stack.
Yeah, okay. So I see how you mean you could implement it with GC, but you could also, in principle, have a RC, and there's nothing in the model that creates cycles. Right. It just creates roots. Okay.
Mm-hmm.
Okay.
And then basically you're asking how complex and rich of APIs can we build around this? And at least for now, while we don't have the full kind of GC integration in WASM where we have objects with fields and stuff, essentially I think the way that most of these APIs are designed is that you just have getter and setter functions that take these capability objects and then get or set values for you. And then I hope it should be clear that you can do whatever with that, right?
Right. So just base building on any refs, you can kind of give them. You probably would want to avoid something that makes you have GC by having arbitrary graphs, but if you have a tree ownership structure, it's just fine. I would think. Okay, that makes a lot of sense.
The other thing about WASM is you can just spin up and spin down these modules pretty easily. So it may make sense to just keep everything alive for a whole HTTP request and then just freeze the whole module and kind of deallocate the whole thing.
It's also worth pointing out that we're talking about AnyRef, but this actually isn't implemented. AnyRef is not fully in languages, fully in browsers, so the APIs are literally all integer indices, but they will very soon, and they're all morally indices into a table which you have locally, and they're all morally these capability objects that will be literally capability objects eventually. Mm-hmm. It's just sort of as a polyfill of getting things done today. They're actually integer indices.
Okay. That makes me feel a little better because I was like, man, it's already implemented and everything. All right. I feel like I don't have more questions. I'm coming to the end. The only thing I could ask is if there are any features in Rust, but it seems like, well, do you think there are? Are there things that you see? Let me back up, I guess. Looking either at WASM or promises. After async await is beautifully polished, is there a part of Rust async story that you think would be better to focus attention on from the perspective of it would help to bridge to the browser? Would it make sense to focus on streams, for example, because that's something that is needed? Or I don't know. If you have any thoughts on that, I'd be curious.
I think from the ecosystem side, all of the frameworks and nice Rust libraries and abstractions are really going to want async and traits, because pretty much everything on the web is async, and so if you have a trait that you want to let users control whatever with, it's probably going to be async. Yeah, I think everything's on the map, right? All the async iteration or stream stuff is also, it's the next piece of the puzzle.
Well, it's all on the map, but the map is going to take a long time to. The question is what ordering and when, but I think if the answer is async and traits because the ecosystem is going to need it, then the follow-up questions they have are probably better posed to ecosystem folks. What about Titone's async trait thing? Will that get you by for a while? Or, what exactly do you want to do with it? Because it async traits is kind of a pain in the ass design-wise. Which subset of features? But I do think that's a common answer. So, okay. All right. Thank you for doing this. I'll let you go back to your lives. Goodbye.
Yeah, thanks for chatting. See ya.
Thanks.
See ya.